And it's a great pleasure to welcome you here this evening to this first event which launches our new series of distinguished lectures in computer science at Swansea. Further details of the entire series for these next 2 semesters can be found on our website at the URL at the bottom of the screen there. On behalf of the Department of Computer Science, I'd also like to express our gratitude to the Learned Society of Wales and the South Wales branch of the British Computer Society for sponsoring this event, and especially to the President of the Learned Society of Wales, Sir John Cadogan, who will take the chair for the event. So, Sir John Cadogan, please.
Well, thank you. This is, as you've heard, one of the lectures in the series put forward by the Learned Society of Wales. It's very much in collaboration with the Computing Science Department here under Professor Tucker and, of course, the South Wales branch of the British Computer Society, who are sponsoring this event, this great event. It's also a lecture in the Learned Society series on the history of science and technology. But what a short history it is. I mean, software engineering is really a very, very new discipline. There have not been many new disciplines. First time I ever heard of it, but I'm proud to say it was early. That indicates that I might know something about it, which I don't, of course. But it was in 1970. I just moved to Edinburgh, and there was one of my colleagues there said, well, of course, software engineering is the future, and so forth. What the hell is software engineering? Totally beyond me. I'm sorry to say it's still totally beyond me. And when my old friend, Professor Randell, who's going to speak to us tonight, is finished, I hope he can spare a few minutes because I've got a big software engineering problem back at home. Now, Professor Randell is, I was going to say, one of the great technicians in this, but actually he's an artist in this. He's been at it from the beginning, has made tremendous contributions, not only to the science and theory of software engineering, but also to its application. And we met many years ago on various advisory committees trying to help people make good decisions. I was not successful at it, but he certainly was. It's a great pleasure to welcome him tonight, this distinguished fellow, this distinguished scientist, and I'm sure he's going to entertain us as well as educate us. Professor Randell.
It is a great honour to find myself talking here and inaugurating your series of distinguished lectures. I just hope that I will not disappoint you too much. I have a considerable interest as a historian of computing, but my special interest in that area really has covered the period from about 1800 to 1950. To talk to you now about the history of software engineering means that essentially I am talking to you as a historical artifact rather than as a historian, because I was involved at the beginning of what some people like to describe as software engineering, as a discipline. In fact, the term software engineering was invented in 1968 to indicate a need rather than to claim an existence. There are many who might suggest that the situation has not changed completely since then. So, Sir John, don't be concerned if you're worried about not understanding software engineering. There's quite a lot of people who claim to practice it who don't either. The then and now, well, the now is obvious. The then that I'm talking about is 1968. 1968 was when there was a conference held in Germany with the title Software Engineering, conference sponsored by the NATO Science Committee. And a lot of people have talked about how significant that conference was. It certainly didn't instantly create a subject called software engineering, but what I'll try and describe to you is what life was like in 1968 with respect to the development of software. And I will end by daring to give some comments on my attitude to quote software engineering unquote now. I'm certainly not going to attempt a complete history of software engineering 1968 to 2011. This talk was first commissioned from the IEEE ComSAC conference to mark the actual 40th anniversary. And I was provided with a few introductory slides because the organizers of the conference realized that quite a few people in the audience then, and I'm sure now, would not even have been born at the time I'm talking about. So positioning the talk by just reminding or telling people a few things about 1968 might get us off to an appropriate start. And so I have retained those slides and incorporated them in this presentation. So, the year 1968. It was the time of the Beatles. Remember them? That was when the Yellow Submarine came into the cinemas. Do you recognize our royal family? Rather a change now from 1968 onwards, but it was the Queen's silver wedding anniversary. The first supersonic aircraft flew. No, it wasn't Concorde. It was the Tupolev Tu-144. Those cars were ones that were very much in vogue in 1968. I wouldn't claim that the Beetle first appeared then. Its history goes back earlier. Much more worryingly, much more serious, 1968 was a time of tremendous upheaval, not least the invasion of Czechoslovakia, when, as they say, tanks rolled through the streets of Prague. I remember that in the sense of, I remember watching television of that, so I was living in the States at the time. I certainly was nowhere near that. I don't know if any of you in the audience remember this or have heard of the actual shock and horror by the, perhaps one might say, rather brave act by the US athletes who demonstrated against racism on the podium at the Olympics. It was the year Martin Luther King and Robert Kennedy were assassinated. That I remember very well. I was lecturing at the University of Virginia. Just visiting there for a day or so, went back to my hotel room, turned the television on, and within about 2 minutes realized that something really major had happened. It was a while before it became clear what it was, but it was the assassination of Martin Luther King. And when I flew back to New York City, I remember being taken by taxi through New York City by a taxi driver who was clearly absolutely frightened. He believed that there were masses marching on New York City. The streets were empty apart from groups of police at every street corner. And that was an amazing time to be in America. America changed incredibly in 1968. I just hope we don't have many more years quite like that. So, anti-Vietnam War protests, those very much were a feature of 1968. Student protests, particularly in Paris. And that is the background to the trivial things about computing in 1968. It was quite a shock to me when I was given these photographs. I'd remembered some of those things, but certainly not others. And so, as a historian, or an attempted historian of science, I belatedly became aware of what one might describe, what I think is described as an internalist view of history, where you just ignore what else is going on. To try and think about computing in 1968 without positioning yourself to know at least a little bit more about what was happening in that year is really a rather bad mistake to make. And as I say, my thanks to Professor Falvey for those photographs. So, that's, if you like, the introduction. Computing in the late 1960s, thank you, was certainly very different to what it is now. Computers were very large, they would typically fill a room, they were very expensive. The thought of an individual owning a computer was just unthinkable. They were owned and operated by large organizations, government, industrial, and so on, used for very big calculations, very big data processing, and the like. There were things that we called mini-computers. Those mini-computers were about the size of a rather small car at that time. And a really well-equipped scientific laboratory might have such a computer, and that was as far as things had got. Certainly, the notion of a personal computer yet to exist, and all sorts of things that have been around for a very long time had not actually been invented. Such things as databases, networks, distributed systems. All of those were yet to come. Yes, there were things like Fortran and COBOL and some early operating systems and the like, but an awful lot of modern computing just did not exist in 1968. Local area networks, the Ethernet and the like, had not yet been invented, but there were the first attempts at linking computers together in what became ARPANET and what led on to the internet. But that's where we were in 1968. Oops. Now let's talk about software. In the late 1960s, the word software was actually being used. The term, as I mentioned earlier, the term software engineering was not. If you look very hard, you can find a few mentions of it in various bits of literature, but essentially the term was a surprise, and it was a surprise to all who were invited to this NATO conference in Garmisch in 1968. The people who were invited were a mixture of academic researchers, industrialists, government officials, and the like, people who were involved in thinking about or developing software, people who were responsible for important software systems or software installations and the like. And they, to a large extent, thought of software as something that either came, quote, free, unquote, with the expensive computers that their organizations had bought, or software that was being developed very specially for their particular individual needs and their particular computer and environment. If they had any thoughts of changing from one computer to another computer, perhaps because some other manufacturer had produced, or perhaps even the same manufacturer had produced a new, more powerful computer, then in all probability they would have to throw away all of their software and start again from scratch. That was the sort of situation then. But one of the reasons for calling the conference was that a number of organizations were starting to become very highly dependent on big computer systems and on the software running on those systems. And it was becoming visible, publicly visible, that a lot of big software projects were going very badly wrong. They were delivering software which was unreliable, did not perform well, had gone grossly over budget and like, assuming they delivered anything at all. So though there were lots of successes, there was some very, very significant failures. There was an analysis done in the States. I can't remember the full title. Involved a study of about 20 big US government-funded software systems. The subtitle, however, was Underestimates and Over-Expectations. And that was a good summary of much of software those days. There was no software industry as such. Software had not been commercialized. IBM, which was very much the dominant computer company by that time, they provided lots of software free with the hardware, so to speak. So there was no space for an independent company to compete against this. Competing against free is essentially impossible. But because of the legal constraints that IBM was placed under, they were forced to unbundle. Unbundle, in other words, to charge separately for their software rather than their hardware. And in 1968 that was looming, and that was quite a big issue as to whether and when IBM would unbundle, what the price of software would then be, and what impact would that have on future developments of the field. The notion of packaged software and the idea of going into a shop and buying some software in a fancy box, or even more now, of downloading it from an app store, that was something that was far from anybody's thoughts. So the NATO conference title, Software Engineering, was intentionally provocative to indicate that software was becoming very, very important, and there was a need to be much more certain about the likely quality of what was being produced, how much it would cost to produce it, and how long it would take, and the like. Parenthetical comment. Some years ago, I had the privilege of investigating the hitherto secret code-breaking computers at Bletchley Park, the Colossus machine and the like. And I remember one of the brilliant engineers who I interviewed in the late 1970s, when for the first time in 30 years he was allowed to talk about his work. He was a splendid character, and one of the things he did was brag about what an engineer was. And he said, any fool can build something for, say, 20 quid. It'll take an engineer to build it for 5. He had another one as well, which was, anybody can build a bridge which will stand up. It takes an engineer to build a bridge which will only just stand up. So there's some interesting baggage to the word engineering here, and things like that I think were in the background of the minds of the people who invented the term software engineering and chose it for that conference. My involvement was as a participant and as co-editor of the report that was written following the conference. In fact, the whole aim of the conference was to produce a report. The number of people at the conference, I think it was about 70 or 80 of us, if I recall it. But right from the start, the conference was organized with the idea of trying to produce a skeleton summary to agree on main points and so on, and then have a report produced which would be aimed at several levels of readership, from senior government downwards. And that was what we were supposed to do. And amazingly enough, that worked. The set of people who had been brought together, many of whom had never met before, but there arose an understanding of a common concern, common purpose, common interest. And the conference was incredibly intense. It was intense in the sessions, between the sessions, and the like. And many of those who attended it have talked about how it was in many ways a really major impact on their career. The late Professor Edgar Dijkstra, for example, went on record as saying that conference had a major impact on his decision to devote a lot of his further career on the problem of trying to prove programs were correct, to develop programs in such a way that they were guaranteed to be correct. Interestingly, I went in a different, more cynical direction soon after that conference. But a year after that conference, I was back at Newcastle, and I launched a research program on the question of to what extent can one get reliability from a software system, even if one admits that there are still bugs in the software. I think that so far history shows that I made a reasonably cynical but correct choice in tackling that topic. The other editor was Peter Naur. Peter Naur, famous as the editor of the Algol 60 report, one of the most brilliant documents in the history of programming languages, I would suggest. Peter Naur and I were equipped with the results of all of the discussions at the conference itself. The conference lasted most of a week, and we then moved into central Munich with 2 or 3 helpers, and we spent that second week actually producing the report. We were working from lots of detailed notes, lots of tape recordings, and lots of documents that had been produced either before the conference or indeed during the conference. So we had a lot of material to work from, and we had a very good structure to work with. But we were therefore feeling it really quite appropriate and quite practical for us to try and minimize our own personal, shall I say, personal attitudes in the report. So we tried just to do it by means of quoting things that were said or things that were written by the various participants, of course ourselves included. Initially, Peter Naur suggested that we only use quotations, and we just fit those together in the structure that we developed from what we've been given. In fact, I persuaded him that we needed some connecting text, but that could be connecting text which was there to make the document flow, not to put over points that we felt should have been said and that we couldn't find a quotation to support. Doug McElroy, a name that ought to be known to the computer scientists here, the whole Unix project took place under his indirect leadership. He was sometimes known as Macro McElroy because he invented macros. He is and was really quite an important figure and quite a character. And I treasure the summary that he made of our report as a triumph of misapplied quotation. Because, of course, we were fooling ourselves as editors when we were saying that we were minimizing our own impact. Our impact was that of selection and position. And you can have quite effect on a report, whether you want to or not, just by doing that. But anyway, a triumph of misapplied quotation, I'll live with that. That report was distributed very widely. NATO printed off large numbers of copies, and it was only some years later that I learnt that Alan Perlis, another participant, who was the head of computer science at Carnegie Mellon University, probably one of the most important computer scientists in that sense, therefore, in the States, who apparently came into the room where all their graduate students were with a great big pile of blue books saying, here, take one of these each. Read it, it'll change your life. So that was the sort of dramatic feeling about the report from the people who'd been at the conference, because they felt that how important the conference was and the extent to which this use of quotations from it were captured all the things that we wanted to say. The sort of things that were being described at the conference were a number of the very big projects that had gone wrong, those that hadn't gone wrong, what sort of techniques might prove to be useful in the future. There was just one talk on what we would now call a programming system, a system which would help a group of programmers organize their work, maintain copies of the various versions of their pieces of software, and help them put together a completed end product. There was just one of those, and that was regarded as a very revolutionary, ambitious, and risky idea. Think how things have changed. There was one paper I recall prefaced by an agonized statement along the lines of, if only we could more often not start again from the beginning, but try and do the same thing several times so as to learn from it. It was said more elegantly than that, but it was illustrated by a very dramatic graph of the amount of effort that had been needed in a particular software department that produced a sequence of 3 Fortran compilers. The same little group 3 times wrote a compiler for Fortran. And the size of these compilers and the cost of making them went down really dramatically. But that was the sort of experience that almost nobody had. That notion of doing it again and doing it better second time and third time. The hotel where the conference was held was rather splendid. That's a picture of it. That's the picture of the view of the terrace where we gathered for coffee and the like. A few years ago, there was a splendid book written by Donald Mackenzie on the nature of proof. I think the title was Mechanization of Proof, something like that. And one of the chapters that he included in there was essentially the story of this conference. But at the time, none of us could remember where the conference had been held. I went through all of my color slides and I found that previous picture which actually shows the name of the conference. Donald being Donald, I should explain that he's one of Britain's most eminent social scientists at the University of Edinburgh. He went and stayed at that hotel as a sort of act of homage. That was the phrase that he used. A couple of pictures from the producing the report. That's Peter now on the left. That device in front of him is called a typewriter. The thing on the right, on his right, is a tape recorder. That's me, by the way, in the back, on the right. I apparently seem to be doing things without any mechanical aids whatsoever, other than perhaps sellotape sticking all that paper there. So we produced that report, and as far as I was concerned, that was it. But then the organisers of the 1968 conference decided that it would be a good idea to have a successor conference. Peter and I were asked if we would co-edit the second report. He wisely turned this down. I spectacularly unwisely agreed to do it. John Buxton, who died tragically about a year ago, he joined with me, and we had, in fact, a totally different experience, because the conference was as unsuccessful socially as the Garmisch conference was successful. It became extremely bad-tempered, where in Garmisch, people who thought they had some possible solutions, and people who undoubtedly had some problems, were happy and willing to talk to each other and to see whether anything could come of it. The opposite happened in Rome, and a great gulf appeared. And indeed, perhaps some of the most important discussions about Rome were about that. But also, it turned out that the organisers had a hidden agenda. They wanted to create an international software engineering institute, and this conference was part of the politics of gathering support for that. Tom Simpson from IBM, author of one of the first operating systems ever developed in IBM, a rather splendid Texan character. He produced a satire, and I'll come in more detail about that in a moment. But that completely torpedoed the idea of an institute, and nothing was ever more heard about that. And in big contrast, there was no agreement at all on the intended contents or structure of the report. So we had a very, John Buxton and I had a very different task. Part of the lack of success, I think, was the hotel. You probably can guess from the name of the hotel that it wasn't exactly one where gastronomic and other aspects of style were to the forefront. The six of us involved in doing the report had been asked whether we would like to do that by staying on at the hotel. We made it very clear we didn't want that. And so we moved it into central Rome. I was overconfident about producing a second report because this time we had a couple of technical writers, and John and I both took our secretaries with us to the conference. There is one incident that is a bit of a diversion, but I so much enjoy the memory that I can't resist telling you about it. That six of us in a minibus arrived Saturday morning in a very nice hotel in the centre of Rome, just across from the Forum, accompanied by mounds of equipment, luggage and the like. The miniskirt era had arrived in Britain, but it hadn't arrived in Italy. So to have two secretaries arrive in Italy from Britain caused somewhat of a sensation. This hotel, when we marched in, there were lots of little old ladies sitting around in the lounge, and they watched agape as we all processed in, following a little army of porters. Because we were so early, the hotel had suggested that we all check in initially just to the suite where we were going to do the work. Our individual rooms would be ready later. So, 10 minutes later, the last of the porters had bowed himself out of the room, and we stood in the main room of the suite, surrounding this pile of luggage and equipment, just looking at each other. And John Buxton said, "I've got a great idea." And we said, "Yes." He said, "Why don't we phone down to the front desk?" He said, "Yes." "Yeah, phone down to the front desk and ask for 2,000 foot of colour film and a stronger bed, please." And that set the atmosphere and essentially allowed us to survive what otherwise I think would have been a horrendous week, because just about everything went wrong. And I list some of the things there. By the end of the week, the suite's bath was full of discarded, no longer working equipment. And I mean full. But we completed the work. Oh, one picture of the four of us there. Sorry for the quality. We completed the work despite the fact that my secretary Anne had to type half of the report on a German language keyboard typewriter. It was all we could get hold of. We managed to break the local computer department's Xerox machine. But we managed to complete the report by the Friday evening, and we set out to have a splendid celebration meal. And that was the evening all the waiters in Rome went on strike. I have strong memories of Rome, I tell you. And really, to cap it all, afterwards, we were forced, quite literally forced, to remove the text of Masterpiece Engineering, which was Tom Simpson's contribution, the one that had torpedoed the Institute. We were forced to remove that from the report, because we felt it would have made a good set of conclusions. Cynical ones, but nevertheless. There is some of the censored text. He started out by saying that he'd been walking around the hotel garden the previous evening, and he'd stumbled over a stone, gone back and looked at that stone, and found that it said, here in, was it 1568, I forget now, the first conference on Masterpiece Engineering was held. And he said, so I investigated this, and I found out about the history of the Institute of Masterpiece Engineering. The problem was that in those times, paintings were very expensive. A lot of them weren't very good. It was taking a long time to produce them, and so it was felt that it was necessary to change the way that everything was being done. First thing was try doubling the number of painters. Would that improve productivity? Find out means of measuring productivity. How about number of brush strokes per minute? That was then used as a criterion for assessing the quality of the individual painters. But none of these, as it says there, none of these advances in knowledge seem to have any real impact. So they decided the problem was not a technical problem, but a management problem. So they went to one of the painters, one of the better ones, Mr. L. Da Vinci, and promoted him to be manager, putting him in charge of procuring paints, canvases, and brushes for the rest of the organization. He ended up by saying something along the lines of, I'd leave you to consider whether in a few hundred years anybody listening to the results of our discussions will react as you have just reacted to these comments about Masterpiece Engineering Institute. as I say, this killed the idea of an international software engineering institute as dead as you could imagine. It was itself a masterpiece. So, what's happened since the NATO conferences? An oversimplification is to say that the world of software has divided into two different parts. There is the part which I've called bespoke software, the development of special purpose software, possibly to be used only in a single location, for a single client, large military systems are still rather like this. And this software is very different indeed from this of the mass-produced software. The software which, well, we would talk about packaged software. Packaged software did not exist in the 1960s. Personal computers and the like did not exist. If you were an organization that had a large computer, then by soon after the 1960s, you might have one database system. You certainly didn't have the choice of dozens, all of which had been used by lots of different people with reviews available and an ability to decide which was the best of the evolved software. Software packages today contain amongst them a wonderful set of very usable, very useful, very sophisticated software. But it's been done through evolution. Nobody in their right mind buys the first or the second system from Microsoft, but the third one tends to be pretty good. And that is the sort of situation of Darwinian evolution which has been very, very effective. But that is exactly what cannot happen in something like the NHS, National Programme for IT, arrogantly claimed to be the world's biggest software system. It was essentially one system, or rather one system of systems. No chance of evolution. And they're just two different worlds. And my view, I'm afraid, is that the bespoke software world, though it is now delivering much bigger, much more sophisticated, or attempting to deliver much bigger, much more sophisticated software than the bespoke software industry of 1968 and 69, is still suffering on this larger scale from very similar systems. I urge you to go and read the 1968 report. Don't bother about the 69 one. Read the 68 report, and I think you will be intrigued to find out how much in there still sounds really rather relevant. But the big software industry that of huge numbers of companies from small to ginormous that now exists is not in that world. It's in the world of essentially of packaged software. A world which was unforeseen in 1968 and 69, indeed, as was the little subworld, the computer crime industry. So, at this point I'd like to make some comments about three particular areas in what people these days are calling software engineering. In fact, before I get to that, let me mention that after those two conferences, I spent 10 years deliberately refusing any invitation to lecture on software engineering or to write on software engineering. I did so because I was appalled by the number of people, academics largely, or salesmen, who were claiming that what they were doing deserved the title software engineering. I only broke that self-imposed purdah, if you like, when I was invited to give a talk at the Software Engineering Conference in 1978 as one of 4 keynote speakers. I was asked to talk about software engineering as it was, Barry Bain to talk about software engineering as it is, Vladislav Tursky about software engineering as it will be, and Ed Dijkstra, software engineering as it should be. I had to rescue him from the discussion that followed his talk. Anyway, so in the world now, which many people will refer to as software engineering, which of course does include a considerable amount of very good work, there are some areas which I still find really rather disappointing, and I'll be intrigued to see how people react to my choice. The 3 topics are software components, software development tools and environments, and multiprocessor system design. I might mention that over the period 66 to 68, when I was back again at IBM Yorktown Heights, I was working on a project, probably one of the world's first projects on multiprocessor system design. So I have a certain amount of history to back up my cynicism here. So, summary view, there's of course been progress in all 3 areas, but I think it's been quite disappointing. There's been other areas where I would not be so critical. There was one sort of invited keynote talk at Garmisch in 1968 by Doug McElroy. It was a talk on software components, and it really was one of the hits of the conference. I think I have some quotes. Yeah, I won't attempt to read that. I'll leave that up for you to read while I talk. Doug McElroy was from Bell Labs, and he had been very much involved technically and managerially, as I say, in the work on Unix and in the style of programming that became popular in Unix, of gluing small components together using things like pipes and filters and so on, and producing very high quality software, really very economically, and doing so by the notion of having a components industry. The notion of a components industry is, of course, old hat in any ordinary sort of engineering. But he had this vision, which he describes, the quote there, of a world in which people would write their future software by deciding what sort of components they needed, and to a very large extent being able to find those components already visible, available to them in a library, and then being able to take those components and from those rather general versions of the components automatically produce specialized versions, specialized for their environment, for their particular characteristics, for example, time, space, performance, generality, and the like, and be absolutely confident that the resulting specialized components would be highly efficient and reliable in the system that they were intending to build. That was his vision. Unfortunately, I would say that with few exceptions, and the Unix world, of course, being one of them, which already existed when he wrote that, that has not really come to pass. There is quite a tradition these last few years of building systems out of a small number of very big, very major components, like a complete operating system, a complete user interface, database, a small chunk of application software. And that is a way of very quickly producing a system. But as Butler Lamson, a Turing Award winner, has pointed out, when you build a system that way, you tend to use a very small fraction of the software that you've cobbled together. Your program, as he said, consumes 10 or 100 times the hardware resource that a fully custom program would have done. You write only 10 or 1% of the code, perhaps, anew, but what you've got is far from that notion of producing really efficient systems from automatic specialization of high-quality general components. So that's a comment, if you like, about software components. I can think of one way in which, interesting way in which things have improved, and that is with the idea of having programs, interfaces being represented or using as their protocol XML or whatever variant of that. Essentially having inputs and outputs be to a degree self-describing, at least with respect to their syntax. The semantics, of course, is much more important and much more difficult. But nevertheless, that is a step forward in being able to glue systems together. But that's not getting around the issue of performance. There were wonderful comments made at Garmisch about software development. One of the ones I like is the second one there. We build systems like the Wright brothers built airplanes. Build the whole thing, push it off the cliff, let it crash, and start over again. But I've prefaced that with another quote, because I don't want you to give the impression that at Garmisch everybody was rubbishing all the software that then existed. There was a lot of successful software. It tended to be the rather more modest systems, but a lot of people had successful careers, and there were companies that were successfully using software. The issue was the very large systems, and it was the bad ones of those that we concentrated on. As that further quote says, certain classes of systems are placing demands on us which are beyond our capabilities and theories of methods of design and production. There are many places where there is no crisis, but where we are being overambitious, that is where we were getting so crises. Andy Kinslow, the last one there, a fellow IBMer, he was in charge of the IBM time-sharing system, which was IBM's disastrous attempt to produce a system which made use of the paging hardware on one of the large IBM 360 machines. For those of you who remember such machines or have heard about them at your mother's knee, so to speak. And his comment there, personally, after 18 years in the business, I would like just once to be able to do the same thing again. Just once to try an evolutionary step instead of a confounded revolutionary one. You can almost hear him crying when you said that. And the power of literal quotation into a report from such a conference was, I think, illustrated by that and many other such quotations. So you could really feel what people were trying to say. So, as I said, for very large bespoke software, I don't think things have changed very much. Software development has fragmented terribly. There's a ridiculous number of different languages, different programming systems, methodologies, platforms, standards. 2 or 3 years ago, I remember hearing a whole sequence of talks from our master's students. And they were talking about work that we were doing on distributed systems. each of them started with about a 15-minute description of the various different standards that they were going to use. A question I asked one of them was, are these standards part of your problem or part of your solution? He wasn't good enough to realize quite what I was asking him. The History of Programming Language conferences, for a number of years, they were maintaining a register of programming languages. They stopped doing that a few years ago. They already had recorded 8,512 different programming languages. Now, I'm not arguing there should only be 1 or 2 or 6 or 10 or even 12, but 8,000? The quote from Les Hatton is wonderfully frightening, if you like, to put it this way. We encourage students to work on real projects. One of my colleagues had students submitting projects in 1 year in C, C#, C++, Java, PHP. You can read that faster than I can. I would note that he ends up with Etruscan. I just wonder whether that's the name of an actual programming language yet. So, with this amount of fragmentation, lots of communication, duplication and the like, there are a whole set of development communities, a whole set of research communities, which essentially do not talk to each other. They do not learn from each other as much as they could. Now, there will be people in some of those communities who are much wiser than that and do pay attention to their colleagues elsewhere. But their life, I think, is made unnecessarily hard by the number of communities and the way that our subject has developed, and the fact that it is not rationalized as much as I think it could and should. Not that I know how to make it do that. I'm just bemoaning, I'm taking the liberty of an elderly retired gentleman to bemoan the present situation. The third subject is that of multiprocessor system design. There's a overly lengthy quotation there. Manny Lehman was the director of Project IMP at IBM, and say that was, as far as I know, one of the first sizable R&D projects on multiprocessor system design, and that rightly and soon focused on the problem of, okay, we've got all of these computers, they can talk to each other, they could share memory or whatever, but how do we get high performance out of them? How do we program them so that the parallelism that they're capable of can actually be exploited by the software? Gene Amdahl was one of the chief designers in IBM of several of their big computers, and he produced something that we called Amdahl's law. Amdahl's law was essentially an assessment of the effect on system performance of limited ability to achieve parallelism in a program. Let me give you an example. If you have a program, a task, which is made up of 100 subtasks, 99 of which can be performed independently of each other, and hence can all be performed in parallel on separate computers. But there is just one task which has to be done either before or after one of those others. Then your calculation is not going to take the time to effectively do one task, one subtask, but two subtasks. And you will be, from just that one little bit of inability to parallelize something, you will lose 50% of your utilization. The time taken will be double what you hoped it would be. Now I'm talking about multiprocessor system design because that has become a fashionable topic again. So the phrase that people talk about now is multi-core. Problems don't get solved by being renamed, though it's a sort of time-honored attempt to do so. The high parallelism works is effective in a number of special cases. When it's very low levels of parallelism, like say 2, 4 or 5 or 6, which is the sort that the advertising will now tell you your latest PC has got or will have, almost certainly will be making very poor use of those processors, getting an average utilization somewhere over 1. The other place where it works spectacularly successful is what I've seen described as embarrassingly parallel programs. None better than search. And who do I mean when I say search? Of course I mean Google. You can throw an indefinite amount of parallelism when you've got a huge amount of data to solve, because there is little or no dependency between those tasks. But all you've got to do is stop when everybody has found all of the information that they can in their particular search space. There are in fact quite a large number of embarrassingly parallel programs, but the trouble is they all seem to be rather different from each other and need to be sort of researched and developed pretty well separately. So it's more like producing a whole set of different recipes rather than coming up with some science of parallelism. There's been a lot of publicity recently for big new projects on multi-core computing, caused, of course, for a very good reason, that the semiconductor companies are unable to gain the performance they wanted from putting ever more sophistication and complexity into the design of processors so as to use up more and more transistors productively. So instead of doing that, put multiple processors on a chip, multi-core chip. The trouble is that in all of the publicity I've seen so far, and I hope somebody will one day re-educate me on this, okay? What I've read has described needs, which certainly exist, plans which exist, and large grants, which at least in America have existed. Very rarely ideas and never solutions. So that is my take on multi-core, work on multi-core at the moment. And I'm making that comment, including from having been involved in a number of pretty large research assessment panels and the like. So, let me conclude. Software engineering, but please remember that I'm putting quotes around that in many cases, has indeed come a very long way since 1968. The reports are available online. They, however, Google, with very parallel search, would very easily find them for you. The trouble is that I can't avoid remembering this phrase, is making great strides has no sense of direction. That wasn't on my school report. I think at times it could have been. I wonder whether others share my disappointment about these three areas: software components, software development tools and environments, and multiprocessor system design. So I end by asking myself a question. In this field, which I've intensely enjoyed being part of, which I still continue to work in with great pleasure. I still have regrets that such important areas are ones where I have still, perhaps pessimistically, considerable doubts as to the extent to which there'll be progress in the next 40 years. I won't be around for that, but a number of you may well be. Good luck.